Think back for a second to the very first time you learned to walk. You took this incredibly wobbly step, you completely lost your balance, and, well, you fell.
But you got right back up, right? You tried to place one foot in front of the other, and you fell again.
And again. And again. But here's the truly incredible thing about that. Nobody called it a failure. Everyone around you just instinctively knew that learning absolutely requires repetition. Whether it's playing the guitar, mastering a sport, or just reading a book, every single meaningful achievement in human history comes from repeated attempts.
So that brings us to a really fascinating question. Why do we get so intimidated when computers repeat? Why does the word loop sound like some terrifying trap we can't escape? What if computational loops are simply human repetition made visible?
Welcome to this explainer. Today, we're diving deep into the very heart of human learning using Ravindra Nayak's fantastic book, Teaching Python to Continue. And hey, don't worry, you absolutely do not need to know a single line of code for this. Instead, we're going to explore how patience, habits, and growth allow both humans and computers to repeat useful work.
You see, most programming courses just throw technical syntax at you and totally expect you to memorize all the rules. But this approach, it's completely different. It teaches loops as thinking. It actually begins with observation. Because before a computer can successfully repeat a task, a human has to understand why that task is even worth repeating in the first place.
Section 1. Why loops exist. Repetition in human life. Loops exist for one very simple reason. A useful action often just needs to happen many, many times. Just look at our own daily routines. We have a teacher grading a stack of 30 notebooks, a doctor reviewing patient reports, a parent packing school bags every single morning. Seriously, computers didn't invent loops. They just formalized the chores we literally already do. And since we don't fear a teacher grading 30 tests, we really shouldn't fear a computer processing 30 data points.
Moving on to Section 2, the hidden pattern, how learning takes shape. So how does a stumbling beginner actually become a master? Well, it happens through repeated exposure and feedback. Learning always starts with practice, that repeated action. Eventually, you reach pattern recognition, where you start anticipating what actually comes next, and finally that blossoms into mastery, a rock-solid, dependable understanding. Computational loops aren't these mindless speed engines. They're exactly this structured pathway from practice all the way to pattern recognition.
Next up, Section 3, the human loop, the cycle of attention.
Whether you're an elite athlete, a musician, or a programmer, you follow a very specific cycle of attention. A loop is absolutely not some frantic blur of speed. It's a calm, deliberate routine. First, you notice. You find your current focus. Second, you do, performing that useful action. Third, you check, reviewing the result. And fourth, you continue, moving on to the next item, but only if work still remains. A true loop is just this attention cycle, executed with total patience. There's this absolutely brilliant concept in the book that says, a loop with feedback becomes a conversation with reality. Checking your work isn't just some afterthought, it is literally the heartbeat of a responsible loop. Without feedback, your plan is basically just a monologue. But when you observe, act, and check the results, you are actively listening to the real world.
Section 4. The end of copying. Why manual repetition fails.
Think about it. If we don't build loops, our only alternative is manual copying. And copying things by hand, that eventually creates absolute chaos. Imagine having to write the exact same daily reminder by hand, 500 times. Or, actually worse, suddenly realizing you made a massive typo on copy number 3. Copied work is just incredibly fragile. A loop, on the other hand, is elegant. It applies one central, perfectly safe rule to as many items as you need, completely replacing chaos with a calm, unified structure. Because here's the thing. Duplication creates hidden responsibility. By keeping the rule in a single source, loops make any future changes completely safe. They reduce scattered, messy code and allow you to easily test one core idea before applying it to 1,000 items. Loops aren't just a clever trick to make computers run fast. They're a fundamental tool for making human thinking cleaner.
Which brings us to Section 5, the path to mastery, repetition as intelligence.
When we really step back, we realize that noticing what stays the exact same and what actually changes is the ultimate path to intelligence. Everyday repeated actions build that structure. Think of printing a changing number of stars to create a visual triangle, or checking a sequence of student scores to generate a comprehensive feedback report, even scanning daily expenses to ensure budget safety. Pattern recognition is simply taking raw randomness and turning it into a dependable, meaningful structure.
The mind does not need to leap. It can return. Honestly, this might just be the most comforting truth we can take away from this entire explainer. You do not have to understand everything instantly. If a problem is massive, you don't have to conquer it in one terrifying leap. You can divide it. You can revisit it calmly. Repetition isn't a lack of intelligence, it's a highly trained, patient return.
Which leaves us with one final, pretty important question to consider. What useful action will your human loop repeat today? Because your own mastery, your own intelligence, and your continuous growth, they're really all just a few patient loops away.